Good day everyone. Today I will show you how to solve linear programming by graphical method. So first example, young Skyrim bakes 2 breads, A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. So the company has 180 pounds of oats and 135 pounds of flour available. So write the constraints for the problem and the feasible region. So first we can do let x is bread A and y bread B, and then our amount of oats is 5x plus 2y less than or equal 180, and then our amount of flour is 3x plus 3y less than or equal 135. So to draw constraint, we copy this one. So 5x plus 2y less than or equal 180. So we treat it is to 5x plus 2y equal 180. Then when x equals 0, then y is blank. So we copy this one to solve. So 5 times 0, which is our x, is 0, plus 2y equals 180. So we multiply 5 times 0 plus 2y is 2y. And then we copy this one, x equal 180. And then we divide. So y equals 180 divided by 2 is equal 90. And the next is when y equals 0, then x is blank. So 5x plus 2 times 0 equals 180. And then, so 5x plus 2 times 0 is 5x equals 180. And then we divide. X equal 180 divided by 5 equal 36. So next, the graph of constraint 1 should 0, 90 and 36 over 0. To draw constraint number 2 is we copy this one. 3x plus 3y less than or equal 135. And then we treat it is 3x plus 3y equal 135. And then when x equals 0, then y is so 3 times 0 plus 3y equals 135. So 3 times 0 plus 3y is equal to 2y or 135. And then we divide. X equal 135 divided by 3 is equal 45. And next, when y is equal 0, then x equal that. So 3x plus 3 times 0 equals 135. Then 3x plus 3 times 0 is equal to 3x, 135. And then we divide x equal 135 divided by 3 is 45. Equal 45. So, the constraint number 2 graph is constraint 2 is 45 and 45. So we graph. First is constraint 1, 90 here, and 36 here. Yeah, like, so we line. So this one is 90 and 36. And then the constraint 2 is 45. The y is 45 here. 45. And then the x is 45 also. Here. 45. We underline. And that's it. Next example is one kind of cake requires 200 grams of flour and 25 grams of water. And another kind of cake requires 100 grams of flour and 50 grams of water. So find the maximum number of cakes that can be made from 5 kilograms of flour and 1 kilogram of fat, assuming that there is no storage of the other ingredients used in making the cakes. So first, we create a table. So, game of first kind, which is our x, and k of second kind is our y, your grams, and flash. Liability. Cake of first kind is our x, is our floor grams is 200, and our fat grams is 25. Then our y is 100, and then the fat grams is 50. Then our viability is this flour grams is 5,000. And then the fat grams is 1,000. To create linear equation using inequality, 200x plus 100 less than or equal 5,000. Or 2x plus y less than or equal 50. X is 25x plus 50. Y less than or equal 1,000. Or x plus 2y less than or equal 40. Also x greater than to 0. And then we create a graph using the inequality. So create graph. So first is 50. No. So we drop rulers of the Una kay 50 no? So then we drop 50 y and 25 x. 50 x. And then 2 divided by 40 is 20 over 40. Then next, to find the maximum number of cakes, so and then this is 20 and then to find the maximum number of cakes, so we x equal z equal x plus y. We draw a table. X, y, z, x plus y. So the x is 0, 20, and 25. And then the y is 20, and 10, and 0. And then z plus x, z equal x plus y is 20. 20 plus 10 is 20. 25 plus 0 is 25. So clearly, z is maximum at coordinate 20. Then so the maximum number of cakes that can be baked is z equal 20 plus 10 equals 30. So now another example. A company produces two types of products, product A and product B. Each unit of product A requires 2 hours of labor and 1 hour of machine time, while each unit of product B requires 1 hour of labor and 3 hours of machine time. The company has 100 hours of labor and 120 hours of machine time available per week. If the profit for product A is $50 unit and for product B is $60 unit, how many units of each product should the company produce to maximize profit? So first, let X represent the number of units of product A, and Y represent product B. So the objective representing the profit of maximize is E equal 50 X plus 16. And then we constrain to x plus y less than or equal 100. This is our labor constraint, labor and our x plus 3y less than or equal 100. This is our machine time. Constraint. And then now, let's graph the constraint to find feasible region when y equals 0, then x equals down. So we got this one, 2x plus times 0. I want to equals 100, and then 2x plus 0, so 2x equals 100, and then we divide x equals 100 divided by 2 is equal 50, and then when x is equal to 0, then y is equal to that. So x 0 plus 3y is equal to 120. So 0 plus 3y equals 120, and then we divide y equals 120 divided by 3 is equal 40. So this one, first constraint, our labor is to the graph is 0 for 100 and 50. Our first constraint sa labor. And the graph machine time is 0 for me and 120. We got our first constraint labor and machine time, so we graph. So first, the y is 100 here, and 50 here. Then we is 100. And then next is the machine time, 40 here and 120. So draw the line. Next example, which is number 4. Nutritionist wants to create a diet plan that includes 2 types of food, food X and food Y. Each serving of food contains 10 grams of protein and 20 grams of carbohydrates, while each serving of food Y contains 15 grams of protein and 10 grams of carbohydrates. The nutritionist needs to ensure that the diet plan contains at least 200 grams of protein and 150 grams of carbohydrates. If each serving of food X costs $2 and each serving of food Y costs $3, how many servings of each food should be included in the diet plan to minimize costs while meeting the nutritional requirements? So first, we let X is equal number of serving of food X. Then the Y food And then we want to minimize the cost. So C equals to x plus 3y. And then routine cost runs to 10x plus 15y greater than or equal 200. That's our routine. And then B is to 10x plus 15y equal 200. And then when x equals 0, then y equal that. So 10x, 10 times 0 plus 15y equals 200. So 10 times 0 plus 15y is 15y equals 200. And then we divide y equal 200 divided by 15 equal 13.30. The next, when y equals 0, then x equals nothing. So then x plus 15 times 0 equals 200. And so 10x plus 15 times 0 is 10x equals 200. So we divide x equal 200 divided by 10 is equal 20. The carbohydrates. So our carbohydrates to 20x plus 10y greater than or equal 150. We rate this to 20x plus 10y equals 150. Then when x equals 0, then y equals that. So 20 times 0 plus 10y equals 150. So then y 150, then we divide 150 divided by 10 is 15. And next y equals 0, then x equals 1. So 20x plus 10 times 0 is 150. And then next 20x. So 2x plus 10 times 0 is 20x equal 150, and then we divide equals 150 divided by 20 is 7.5. The graph first is the y is 13.33. And our x is here. 20. When we underline and then that our carbohydrates is y is 15 here. 15 and our x is 7.5 here. 7.5. Then we put a line. So that's it. Our last example is number 5. A toy company produced 2 types of dolls, Barbie dolls and Ken dolls. Each Barbie doll requires 3 hours of molding time and 2 hours of painting time, while each Ken doll requires 2 hours of molding time and 1 hour of painting time. The company has a total of 240 hours of molding time and 120 hours of painting time available each week. If the profit of each Barbie doll is $10 and on each Ken doll is $8, how many dolls of each type should the company produce to maximize its weekly profit? So the solution is, first, let x equal ordinals, and y is candles. And then the objective function to maximize profit is E equals then x plus 8y. In the next, we illustrate 3x plus 2y less than or equal 240, which is our holding time. And then we get this to 3x plus 2y equal 240. Then when x equals 0, then y equals none. So 3 times 0 plus 2y equals 240. So 3 times 0 plus 2y is 240. And then we divide x equals 240 divided by 2 equals 120. When y equals 0, then x equals none. So 3x plus 2 times 0 equals 240. 3x plus 2 times 0 is 3x equals 240. So we divide x equals 240 divided by 3 is 80. So this is our molding time. To painting time, to solve painting time. So 2x plus y, then less than or equal 120. And the next is we make this to 2x plus y equal 120. Then when x equals 0, then y is down 2 times 0 plus y is equal to 120. So y, or y equivalent 1. So y equals 120 divided by 1 is 120. Then when y equals 0, then x equals none. So 2x plus 0 equals 120. So 2x plus 0 is 2x equals 120. And then we divide x equals 120 divided by 2 is 60. So this is our painting time. And then we draw the graph. So we draw the graph. So to molding time, y is 120 here, and then the x is 80. 120. Then we combine. And then the painting time is y 120. And the x is 60. So that is our graph of molding time and